Day first of Read and Talk Challenge. So, uh, the book that I am reading right now, it is the basic of bitcoins and blockchains. And today I read from the page 114 to 100 till now. Let me see. Uh, 50. Yeah, 150. Basically, what I understand and I get from this part, it was the part about cryptography. So cryptography is a mathematical term, and it is used basically for mostly recognized for encryption and decryption, and also for hashing and digital signature. So I will talk about encrypting and decrypting in this video. So we know all about encrypting and decrypting, but how it works. So in this book, it explains very simple and very in a very good way. So there are two type of encryption of, or we can say, transition. We can say, one is symmetric and the other is asymmetric. As you know, by the name of symmetric, it is this kind of scheme or transaction has from the sender and the receiver, they have both one key, that a shared key. For example, me, I want to send a text to my friend, and we already shared to a key, for example, +1. What does it mean +1? +1, for example, if I say I am home, I will change the letter one, the next letter of the letter that I am using, or I want to be I want in my sentences. For example, I will become J, A become B, M become N. So it will be J, B, N. Home, it will also be in the next letter of each letters. And the receiver will understand that they should, because we already know our shared key, he will come back to the previous letter. For example, J will become I. This is symmetric. It has a lot of problem. For example, what if when you share this information, for example, with your friend, you text them let's get the one plus key for our conversation. What if someone else is already watching your conversation, and they will understand all your conversation after all, after that? Or maybe you will get in touch and talk to them directly. What if someone sees you and listen to you? And there's a lot of problems. You can't always get in contact directly, face to face, with your friends. So that is what the asymmetric transaction or scheme will come. That is, in this transaction, we create two keys. One is public key and one is private key. Public key, we send them to the public, like for the name, what as the name it shows, already knows our public key. But the private key, we keep it to ourselves. And the sender, whoever want to send a message to us, they will use the public key of us to write their message. And when the message came to us, or the message goes through internet, no one can decrypt it, because it needs a private key, the private key that you have, and no one knows about it. If I can explain it or elaborate in a simple terms, we can say a public key is like a box, and you send the box to the public, and everyone puts their letter in it, but no one can open it except you. There is a hole in it, and they will insert their letter in it, and you came and you open it with your private key. No one can open it. So it's digitally. Maybe my example doesn't very it doesn't match with this example of real life, but you get my example, you get what I mean to say. And yeah, the crypto or cryptocurrency or bitcoins uses this. And how we create the public key and private key, it's also very interesting. So let's see, for private key we choose a random number from 0 to 2 to power of 256 minus 1. So you can say this number, it is 78 digits. So you can choose a number from 0 to that number, which is 78 digits, which is like trillions and trillions of numbers. You choose that number, you put it in a formula, a function, and they will give you a public key. Public, it will bring you something and it will be your public. You keep that private key to yourself, and you will use that public key to create your account and use it in other thing. But you use your private key only for decrypting and also for transaction, like when you want to send something, you only know that key. So and you might say that what if someone's because we already have our public key, like we share our public key, can they get to our private key by that formula? It's mathematically impossible, because it is mathematically possible. I don't have the formula, but you should know that it's impossible. And if we can guess, like for example, we have the public key, let's test every number like from 0 to that 78 digits. That is that's impossible. It can be, it can't happen. So yeah, that is the encryption and decryption and symmetric and asymmetric. I hope that you learned something, and we will see in the next video. Bye bye.